All right, so again, today we're talking about algebraic reasoning, which is our intro to proofs. We're using ideas from algebra to help introduce this idea of proofs. So, there it is. All right, so again, these are the two I asked you to do at the start of class. First one, what's my first step in order to solve? All right, move terms so that they're on the same side, so we can bring the x across, we can bring the constants across. So it doesn't matter which one you start with. I usually like to move my x first. So on here, doesn't really matter which way you move them. No, I like moving the smaller number when it comes to my x's. So I'm going to move the 9 over this way. Now, you can either show your steps in between. So I could say, all right, minus 9x minus 9x. So we have 6 equals 1x, or just x minus 3. Now, once you have that, there's another step. What's the next step? Add 3 to both sides. Plus 3, plus 3. So we now have x equals 9. Now, that's our final answer for this one. Now, these are algebraic properties. All right. When we balance an equation like this and we add and subtract values from both sides, those are properties of equality when we're balancing an equation. So we have the first one, we use our subtraction property of equality, and then we use our addition property of equality. All right. On the next one, we have some other properties that we have to use to start this off. What's the first thing that we're going to do? Distribute. Yeah, so that 5 has to go to both of those values. So we're going to have 9x plus 5 equals 5 times x is 5x. 5 times negative 3 is 15. Now, it looks a lot like our first equation. Now we have like terms that are on different sides. We have to get them across and combine our like terms. So for this next one, what do you want to move first? The 5? All right, let's move the 5. So here we have a positive 5x. Move it across, we're going to subtract. Now, whether or not you want to show those in between steps, you don't have to. So we subtracted 5, we're left with 4x plus 5. Over here, we're going to be left with that negative 15. What do we do next? Minus 5. All right, so we subtract 5 from both sides. On this side, we'll be left with 4x. On this side, it will now be negative 20. Finally, that 4, we got to get rid of the 4. Divide by 4. So divide by 4. 20, negative 20 divided by 4 is 5. That's our final answer. Now, again, we use a couple of different properties. First one, to get from this step to this step, we distributed. Once we distributed, then we got the x over to the other side by subtracting. Then we subtracted again. And then finally, we divided. So those last 3 steps are, properties of equality. So we're using lots of properties from algebra. And we're going to look at some of these properties from algebra again in order to know how to solve equations and identify exactly what the process was that we're going to. So we're going to identify algebraic properties of equality. We're going to use algebraic properties of equality to solve equations. And then we're going to use properties of equality to solve geometric measures. All right. I'm not having you guys work in a partner on this one. Again, if you want to talk it out together, that's fine. But over here, we have the work for a student. All right. So they solved this equation a little bit longer. All right. And they chose to show every in-between step. So on here, we started off. What's the very first thing that they did? All right. Well, so we wrote the equation. So that's what was given to us. Then I heard in the back, we did what? Distributed. So this value got distributed to both parts. So that's R over here. All right. Distributed. You had to write that? Yes. Property. All right. Now, once they did that, what was our next step? So what did they do from here to here? What changed? All right, subtract what? All right, the minus 6. So we had 10 minus 6 on that same side. So what could we say we did there? We subtracted. Now we didn't subtract anything from both sides, right? So on this side, we're just simplifying that side of the equation. We combined our like terms or we simplified. So either one of those would be acceptable as what we did here. Simplify or combine. Either one of those would be fine. So again, either simplify or combine like terms. And then we have the next step. All right. What happened from here to here? What's different? So they subtracted 5/2 on both sides of our equation. So that's our subtraction property of equality. All right. So we balance the equation with that. That's subtraction property of equality. So they had a few things listed up here. They're talking about properties of equality, distributive, commutative, associative properties. We're not using commutative or associative right now. I'll go back and mention what those are in just a minute. But you're going to have a lot of the basic properties of equality. So addition, subtraction, multiplication, division, and a lot of either simplifying or combining like terms. So go through and see if you can identify what they do on the remainder of those steps. Yeah, I know. All right, so you have 5 other blanks there. Again, we are using a lot of the same things over and over and over. So again, what we had so far: distributive property, simplify or combine like terms, and then subtraction property of equality. Now, I will do a lot of abbreviating in this section. So property of equality, I abbreviated that. We'll abbreviate things all the time when we're doing proofs. All right, to save on time. So on the next line, we did subtraction property of equality. Then what do we do after that? Well, these disappeared. These went together. What do we do? Combine like terms. So again, same as what we said on that other line. I take, again, either simplify or combine again, same idea. Next one, what'd you do? You subtracted the 9. So what property is that again? Subtracted property of equality. The same one that we already used. Subtraction property of equality. And yes, you should put property of equality because later on we will talk about something else called property of congruency. So there are different properties that we need to know. All right, on here, the next one, we have what changed from that step to this step. What again? They actually subtracted, they did the math, they simplified it. All right, go on to the next one. What happened? So now, if you were doing this problem, you could have said one of two things. You could have said we would divide that off, or you could say that we're going to multiply it by the reciprocal. The work that they showed is multiply. All right, so I'm going to say multiplication, property of equality. Multiplication, I'm going to rewrite property of equality. Again, you could have went either way because whether you divide by the 5/2 or you multiply by its reciprocal, it's the same thing. So then for the last part, again, we simplify. Any questions there? Now, I don't actually want you to go through and do be here. It says identify another method you could use to solve the equation part A. I don't want you to do that. What I just want you to understand is there more than one way that you could have actually done this problem? Yes. Yes. All right. So sometimes we might have different ways that we have our proofs. If I ask you to do a full proof on something, one person might do it one way, somebody might do it a different way, or you might just switch a couple of the steps. That's fine. All right. So, algebraic properties. Now, when you solve an equation, you use properties of real numbers. Segments, lengths, and angle measures are real numbers. So you can also use these properties to write logical arguments about geometric figures. So all of these properties are coming from algebra, but we're still going to use them in geometry because we still deal with real numbers. So these are some of the properties that we just talked about. The first one, addition property of equality. Again, if I have two values that are equal and I add the same thing to both sides to balance it, that's the addition property of equality. So again, we're balancing the equation by adding something to both sides. Subtraction property of equality. Yeah, if A equals B, then A minus C equals B minus C. Again, we're balancing the equation by subtracting something from both sides. Multiplication, property of equality. Again, balancing by multiplying. Division, dividing both sides. So we're balancing an equation by dividing something from both sides. Substitution. We did not use that one yet, but we will use that a lot. So substitution property of equality, if A equals B, then A can be substituted for B, or B can be substituted for A in any equation or expression. So if you know two values are equal, then you can replace them with each other at any time. That's what that's saying. And then finally, distributive property. We just did this one. We did the one with the sum. But again, whether in the parentheses you have the sum or the difference of two values, it doesn't matter. You have a number on the outside, and all you have is addition and subtraction signs inside. It distributes to every single value inside. You multiply it every single term. All right. Any questions on the algebraic properties? Should look familiar, right? Okay, moving on. So now, on this next example, I'm going to put my sheet. So, on this one, I gave you a table because now I want to start looking at this as a proof. I'm going to tell you, on here, on the PowerPoint, it's not written in a table. I'm going to tell you what I want you to write where. So, you have statements, you have reasons. This is how we are going to set up a proof every single time. So now, it says justify each step, all right? So on this one, we want to see all the in-between parts as well. All right. So we're going to write out every single piece. So first, to start off, the equation, this is what I want you to write on line 1. So this over here is going to be line 1 for our side that says statements. Over here, for reason, this would be our number 1 for our first reason. You don't have to write this part in the middle, all right? That's just an explanation of what you're doing. But we have this equation. How do we know we have that equation? It was given to us at the beginning. A proof will pretty much always start with some type of giving. Again, in your table, you just write in the statement and the reason. So now, starting this off, what do we want to do first? I like moving one of the variable first. So if I want to get the variables on the same side, what can I move? All right, I can move 3x. By either moving that over to the right side, or I can move the 4x over to the left side. It doesn't matter which one you do now. Since I have this in a PowerPoint, the one I chose to do was I move the x over to the left. All right, so the 4x. If I want to move the 4x over the 3x, how do I get it over there? Plus 4. Yeah, I'm adding, right? So we're using addition property of equality. So that's going to be our second reason. And I'm adding 4 to both sides. So over here, this is what I'm going to put down for my statement. For that second line, I have 3x plus 2 plus 4x equals 23 minus 4 plus 4x. I added the 4x to both sides. Now, just like we did on the last problem, what can I do now? So I've added the 4. I actually have to do what with those values? So I have these 2 x's here. Now what do I do with those? I combine it, right? So this is simplifying. So I can simplify by combining like terms. So for the next part, we're going to simplify. Again, I really don't care if you say simplify or if you say combine like terms, but we're simplifying. So what are we really doing? We're combining like terms. So our third line for our statement will be 7x plus 2 equals 23. Now what? Subtract. So we're going to subtract 2. So we're using subtracting property of equality, subtracting 2 from both sides. So our fourth line. Doing the subtraction. And again, kind of the same thing all over again. We've subtracted, so now we need to do what? Well, we'll divide in a second. First, we need to simplify. So simplify. Get line 5. Now, we could do away with these in-between steps. So where you see they have these red values here, do we really have to show that line? No, we could do this all as one step. So if I went from, say, this line that we started with the given, all the way down to the third line, and we had 7x plus 2 equals 23, I could have just said from here to there, that was addition property. Or from this third line to the fifth line, we subtracted 2, we took it off both sides, that was subtraction property of equality. And I could have skipped off the whole part about simplifying. All right. So for this last one, we're going to do exactly that. We're going to skip showing the actual part in red. So we're going to use division property of equality. So I could go straight from 7x equals 21 to x equals what? X equals 3. Right. So that would be our. So I didn't use all 7 on that one. Now, again, could we have used all 7 lines? Yeah, I could have shown that one extra step of actually dividing by 3, and then I could have said simplify again, and I would have used all 7 of those lines. But we don't have to. All right. So we're gonna make the next one a little bit shorter. Instead of showing all these in-between steps, we're not gonna show them on this next problem, all right? So let's go back. Oh, yeah, it is always good to check your solution. So we got answer 3. If we plug it in, both sides should be equal, and yes, both sides are equal in this case, or both 11. All right. So on this one, kind of the same thing. We're starting off. The first line is going to be what? The given. What's given to us here is this equation. So we're going to start off. We have our equation. That's going to be the first line. Why? Because it's given. Now, once you know that, now we follow our rules from algebra. So what's our first property we're going to use? All right. So I'll do what's inside the parentheses if I can. Is there anything I can do there? No, but I'm going to do something with the parentheses. I heard it. We're going to distribute to those parentheses. So we got the 5x out front. We're going to take that 5x. We're going to use it to distribute to both of those numbers. So we get negative 35w minus 40 equals 30. But I didn't show that in between step of actually multiplying it to each value at the time. Oh, what did I do there? Sorry. Sorry, that was line 1. Let's try that again. Line 2. All right. Now, from there, what's our next step? What are you going to subtract? Subtracting 40? Plus 40. All right, so we're adding 40 to get rid of that 40. Again, I'm not actually going to show it. I'm not going to actually write it out this time. So I'm just saying addition, property of equality. Again, a lot of times when you do the problem, you add 40 both sides like that. But then on here, all I want you to actually write is that final statement. So this will be our third line. Use addition property, we added 40, and now we have the negative 35w equals 70. One last step. What do we have to do? 5. So again, when we divide, we call that division property of equality. We're dividing by that negative 35, and you get negative 2. So divide, and w is equal to negative 2. So that's our fourth line. So we did this in just 4 steps. All right, I had started doing example 6 in my last class, and I ended up running out of time at the very end. So I'm going to actually skip over to the back. So I'll give you another minute to finish copying this slide, and then I'm going to skip over to the key ideas on the back side of this page. Whenever you're done writing, just flip over to the back. That way I know everybody's done writing. Okay. So, like I said, skip it to the back. Skip ahead. Okay. So, using other properties of equality. So, the following properties of equality are true for all real numbers. Again, we're talking about segment lengths and angle measures are real numbers. So, these properties of equality are true for all segment lengths and angle measures. So now, this time, in this chart, they give us an example of not only how we use it algebraically, like they were showing us in algebra, but also with segment lengths and with angle measures. Now, these are 3 properties that are very important. We tend to use these properties a lot in geometry. So the first one, reflexive property. Reflexive property allows us to say that 2 pieces that are the same are equal. So 2 numbers that are the same are equal, 2 lengths that are the same are equal, or 2 angles that are the same are equal. Now that seems kind of a funny thing. It seems like it wouldn't be very important. But as we go on, we're going to have diagrams of things like a triangle maybe split into two smaller triangles. And part of the proof that we'd have to do for this, we might have to say that this piece is the same in both of these triangles. That's where this idea comes in. Right? We're able to say that this length in this triangle is equal to that length in this triangle. All right? So this is a very important idea, and it's something that we're going to use a lot in our later proofs, the reflexive property. The next one, symmetric property. Symmetric property, if we have an equal statement one way, we can just flip it, and it's exactly the same as our symmetric property. Again, when we're doing proofs, we're going to be given a statement of some sort, maybe an equation, maybe something else, and then something to prove. Our final answer, our final step in our proof has to be the same as that proof statement they gave us at the top. So we got through all the way to the bottom, and then we had it backwards. We're going to have to flip it. So that's what allows us to flip it. And then finally, transitive property. Transitive property and substitution go hand in hand. In fact, sometimes you could use substitution or transitive property. Transitive property specifically says, though, if you have two values equal to the same thing, then they are equal to each other. So A is equal to B and B is equal to C, then A is equal to C. Same thing here. If we know that the length AB is equal to the length CD, and the length CD is equal to the length EF, then we can say that length AB is equal to length EF. Or if we know an angle, measure angle A and measure angle B are the same, and measure angle B and measure angle C are the same. Okay? Then we can say measure angle A is equal to measure angle C. So if we know two values are equivalent to the same value, then they're equivalent to each other. That's our transitive property. Questions there? But like I said, these are three that we're going to use a lot in geometry. Probably even more so than the ones on the last page. All right. So this one's a little more challenging. It's our first time looking at a proof in terms of geometry. And is there more than one way that you could do this proof? Yes. When I started doing this with my first class, I thought they were going to go a completely different way, because the first thing I saw was that straight line, ABC, right? And I was like, all right, we have 180. I can do stuff with that. I can add up all those angles that equals 180. And I was way wrong, because they went a totally different route, and that's fine. There's more than one way to do a proof. So I'm going to walk you through the steps that they used, and I want you to fill them in. All right. On here, they did guide you a little bit as to what steps they wanted us to do. So the very first step, though, same as on the other problems, should always be what? What's the first step again? Given. So what did they give us? Ooh, did they give us anything in there? No, but they did give us that picture. Is there anything in that picture that they told us to start off? A. All right, DDC, what about them? ABC. Oh, ABC? What did they tell us that? There's something marked. A light. Yeah, okay, we got the light. I see the light, but there's something marked. The light equals PVD. How do you know those things? Yeah, these things. Those are congruency marks. So he gave us something. So we want to start with that given. So the first thing that they have in our solution is our given. Now, it was marked on the diagram. It might not always be given up there. It might be something on the diagram that was given to us. So we could be given things up here. We could be given things in the diagram. This time, they gave it to us in the diagram. So those two angles are the same. And you can say it a couple different ways. You can either list out those angles, right? Angle ABE and angle CBE. Or they gave us these numbers to make it a little bit easier. So we have angle 1 and angle 3. Yeah, that's another way that you can name angles. So now, the next thing that they had given us, if you look at the next statement, it said measure angle DBA, so I'm looking at your sheet, equals measure angle 3 plus measure angle 2. All right. What property is that? Angle addition postulate. So Yeah, so that's bringing back our idea from last chapter. So we have these two angles add together, give us this entire angle. That's angle addition.
What chapters do we have? What chapters do we have in total?
Chapters total? No clue. Maybe like 15.
Hey, in the whole
Like you're talking about all year long? I guess probably around 15. Roughly. We're in chapter 2. It's still close to the beginning here. All right. On the next line. So now, look down at the next statement that you have on there. It says measure angle DBA is equal to measure angle 1 plus measure angle 2. What changed? What changed in that statement? Look at your paper. Don't look here. Look at your paper. What changed from line 2 to line 3? Measure angle 3 turned into measure angle 1. How did we do that? Well, substitution. They told us that they're equal up here, so we're able to use substitution to replace that value. Again, as you're filling this out, these are on your paper already. This was 1, this was 2, this was 3. 1, 2, 3. All right, we got 2 more lines. So now it says measure angle 1 plus measure angle 2 equals EBC. How do we know that? Do we know that from any of this prior information? Do we know that from any of that? Or do we know it from the diagram? We know it from the diagram. So if we look at the diagram, there's angle 1, there's angle 2. Here's EBC. That's again our angle addition. So we have these two angles added together, give us that angle. That's how we're able to get line 4. So now, looking at those last 2 statements. What's our last line on there? That's what we're trying to prove. It's this statement right here. That's down there on line 5. How do we go from these 2 statements to saying that? Is that the same? So if this is equal to these 2 added together, and this is equal to those 2 added together, then what does that mean about these 2 values? Must be equal to each other. What property was that on the last slide? It's also at the top of your paper. 2 things that equal to the same value and equal to each other. No, one more transitive. So when 2 values are equal to the same value, then they must be equal to each other. That's transitive. And we will use that quite often. So we knew that they're both equal to the sum of measure angle 1 plus measure angle 2. They must be equal to each other. And that is our first geometric proof. Now, some are going to be easier than others. Of course, the first one's going to be hard because it's the first one. All right. They will get easier over time. There will be some that are challenging though along the way. Down there on the bottom, you can try those 2. What I want you to do though is just take a picture of this, upload it. I'll put a spot for it tonight. I have not done it just yet. I haven't had time today, but there will be a spot for it tonight. So just make sure you get it uploaded so you get credit for doing the notes today and follow along. And then if you want to staple this into your notebook, I have a stapler that you can always borrow. It's over here on my desk somewhere. I just held it up at the beginning of class. I hit it. So if you ever just want to staple something into your notebook, staple it over there on the desk. Find my other one that you just cut up on a pencil sharp. So again, tomorrow, again, you may get a pass in first period for testing. You may not. Again, if you are coming straight here for class, just wait outside the door because there's a good chance that I'll be wrapping up testing this room and there might be a few people still turning in paperwork and computers and things like that. So just wait in the hallway patiently for me and I'll let you know when you can come in. Once I have the door propped, that means come in. So if it's propped when you get here, by all means, come on in. But if it's not, just wait outside.
How long do we wait for, like, max?
45 minutes.
Max?